some more rules of integration. For instance, we studied how do we find the integral of e power x dx. We studied the rule. The rule says that it is e power x plus c. Now, how do we work if we have to find integral of e power say 2x dx? Or suppose we have integral of e power say x minus 3 dx. Then in this case, how do we work? So it is again depending upon this main rule. So to solve such kind of questions, we use the method of integration by substitution. Later in your advanced calculus stages, you will have a direct formula to find the integral of this, but at least you should know how that rule get derived. Now, if you look at this rule, in this rule, what you have e power x means you don't have any coefficient of x. But in the first example, you have e power 2x means there is a coefficient of x. Okay, and in the second question, x is subtracted with a number, subtracted by a number. So in both these cases, you are not able to use this rule directly. So for that, what we will do is we will convert these questions in the form such that we are able to use this rule. Okay, so before we go to that, I hope you are aware that x is a variable. So this rule is valid for any variable, means any notation. Like if you have e power y dy, the rule says same, e power y plus c. Or if you change the variable to say u, then the rule becomes same, but it will be expressed in terms of u, and so on. So the thing is that you can change x to any variable, any other variable. Okay, it's valid for all the variables. So let's understand this with the help of an example. Suppose you have to integrate e power say 2x plus 3 dx. So in this question, I have taken combination of both 1 and 2. Some number is multiplied with x, as well as there is addition or diffraction of two numbers. So now we know that the matching rule for this is this one. But for that, what we need, we should not have 2x plus 3. In place of 2x plus 3, we should have one variable only. So how do we overcome this issue? For that, let's assume that this is u. Okay, so the moment we write it as u, 2x plus 3 as u, so what this integral becomes? It becomes e power u, correct? Now e power u, so we can use this rule on this case, for this case. Okay, now it becomes e power u. So the only other requirement of this rule is if it is e power x, you should have dx. So next thing that we need is we need to get the value of dx in terms of du. So for that, we will use this term. So we got u is equal to 2x plus 3. Since we need du, so it shows that we have to find derivative of u with respect to x. Why x? Because u is a function of x. So what it will be? 2. Derivative of x power 1 is 1 and derivative of constant is 0. So when you simplify this, what you will get? The value of dx. It will be du over 2. So now we will use this value of dx here. So in place of dx, we can write now du over 2. Now you see that we have this half as a constant, that we can take it outside the integral sign using the property of integral, e power u du. Now for this, apply the rule, and this gives you 1 by 2 e power u plus c. Now still we didn't finish with the answer, because our original question was in terms of x. So our final answer should be in terms of x as well. So this gives you 1 by 2 e power 2x plus 3 plus c. So this is the integral of e power 2x plus 3 dx. If we try to understand this, what we notice that whatever is the coefficient of x, it comes into the denominator and exponential function remains same. So this rule can be generalized as integral of e power ax plus b dx as e power ax plus b, because for exponential function the integration remains same, divided by the coefficient of x, which is a here, plus c. Okay, so later in your future studies, when you are working with double integral or other operators, say Laplace transform, you will be using these rules, okay, in other advanced calculus topics. Now we can do the similar thing for all other rules, even the rule for trigonometric function. Let's understand them with the help of example. Like if you have to find integral of sine of 7x minus 9 dx. So again, this can be solved by using the method of integration by substitution. Why we know that? Because if we look at the rule respective to sine, it is only sine x dx. So what we need only x here, but we have here 7x plus 9. So to make use of this rule, we again use the method of substitution. We denote this entire quantity by u. So we obtain here u equal to 7x minus 9. So again, when we differentiate, what we get? 7. So this gives you the value of dx as du over 7. Now use these two values in the original integral. Let's see what we will get. So this is equal integral sine, we are not changing. In place of 7x minus 9, we substitute u, and in place of dx we write du over 7. Again, 7 being constant, we can take it outside the integral sign and we can write sine of u du, which is equal to 1 over 7. Integral of sine of u is minus cosine of u plus c. Because we have used this formula, this says that minus of cosine xt plus c. Okay, returning back to the original variable x, we get here minus 1 over 7 cosine 7x minus 9 plus c. So we get the result that integral of sine 7x minus 9 dx is equal to minus 1 over 7 cosine 7x plus minus 9. So what we observe here is, for sine the integral become cosine. Okay, the only difference is get divided by the coefficient. So we can write the generalized rule in this case as integral of sine of ax plus b dx, where a and b are any constants, is equal to minus cosine, because for sine it become cos, angle remains same, divided by the coefficient of x, which is a plus c. Okay, so in advanced topics of calculus you will be using this rule directly. In the similar basis, we can derive the rule for other functions like cosine ax plus b dx. So as we know that integral of cos is plus sine, so it becomes sine ax plus b divided by a plus c. What we did? We just divided by the coefficient of x. Okay. Similarly, we can work with the power rule. Like we know that the rule of power rule, that is integral of x power n dx is x power n plus 1 over n plus 1 plus c for all values of n except minus 1. So the modified rule or advanced rule for this will become, like in place of x, suppose you have ax plus b to the power n dx. So you don't need to work by integration by substitution. Instead, you can use this rule directly, provided you substitute it directly. Okay, so ax plus b to the power n plus 1 over n plus 1, and it get multiplied with a, the coefficient of x, plus c. Again, this rule is valid for n not equal to minus 1. Okay, so it is with a comes here. Okay, so this is how we work with these rules.